welcome, Mick. Delighted to be speaking to you today. So, if I start with a question I saw recently on an electrical engineer subgroup on Reddit, and it was how do I flash microcontrollers en masse? Can you tell me what the options are for programming or flashing or inserting securely an application's code onto a microchip?
Yeah, sure. So I guess I should explain what a microcontroller is, first of all. It's basically a computer on a chip, and it is used in embedded applications. So if you're looking at, control systems in motor cars, you're looking at implantable medical devices, wireless meters, anything like domestic appliances or handheld devices like, believe it or not, power tools, hair dryers, curling tongs, things like that. So microcontrollers are used in all of them. So when we talk about a microcontroller, we're talking about a programmable microcontroller. Okay. So what they do is they stick a bit of memory onto the side of the microprocessor core, and that then becomes a microprocessor or a series of cores that can be configured by the engineers who design the programs.
Okay, so I'm an engineer and I've developed a new application, let's say for a curling tongs or for a smart white goods, for example, like a dishwasher or something along those lines. How do I get my code onto that microcontroller?
Okay, so I'm going to deal with how do you secure that microcontroller later on in the discussion. So very simply, you have some firmware. You need to basically burn it into the device. That can be done during the manufacturing process at a process called in-circuit test, or ICT, we're going to call it, where this process is in the middle of the production line, where all the devices have already been placed on all the surface mount devices have already been placed on the board. And you basically take the board off the line, you stick it in a bed of nails to test that all the devices are attached correctly. And then at that stage, you can run in the firmware into the device. And the other option you have is you can program the microcontrollers before they go down onto the board. And that is used by various manufacturers because it simplifies the in-circuit test process. There are many test engineers who have been working on in-circuit test algorithms, and they're very, very complex things because you could imagine boards with thousands of devices on them need to be tested, and they hate to see the programming process coming along at ICT because it just further complicates the entire process. So it's very popular these days to program your devices before they go down onto the boards. That can be done either by the manufacturer or the contract manufacturer themselves, or more popularly by outsourcing the programming of those devices to companies like EPS Global.
Okay, and I would imagine that it speeds up the process somewhat of ICT if you don't have to take the board off and program those chips at that point.
Yeah, very significantly. So if you could imagine a train going down the line, and there's a blockage at ICT, which slows the entire train down. How do manufacturers usually get over that if they want to program the devices in ICT? They usually put more testers in the line. Now, these testers cost $1 million each.
Wow.
So in a lot of cases, I often think of toll booths where you're driving along the road and then you need to pay a toll, and then the road spreads out into a dozen or so toll booths because it's a very slow process.
Yeah.
And that's the same as ICT. So what manufacturers tend to do is they tend to try and make that ICT process as efficient as possible. So if you could imagine an SMT line where, say, the beat rate of the line was, say, 60 boards an hour. So they're getting 60 boards every hour out of the line. The more complications they experience at ICT slows down that line. So whereas they may have the pick and place capability to build 60 boards an hour, the actual programming overhead adds some time to that. So it could slow it down to 50% of that or 25% of that. And to counter that, they put in more testers, or they program the device before it goes on the board. Now, programming the device before it goes on the board doesn't simply take that time overhead away. It has another or several other advantages. One is that when you program a device off board, it becomes live and it becomes bootable. So it means that as soon as the device is placed on the board is switched on at ICT, it boots straight away. It has the program already in it. And again, the poor unfortunate test engineer who has to manage the test algorithm, his life is made significantly simpler if he doesn't have to provide the test to devices that haven't been programmed yet.
Okay, so they're live on the board and they can test all of that, and it makes it significantly simpler.
That's right. Yeah.
Okay, and is that what's called off-board programming, when the chips are programmed prior to being placed on the board?
Yeah. So if you could imagine something like an automotive application where the required standards are very, very high, the off-board programming has evolved over many, many years from simply a task that needed to be done into a task that needed to be controlled to quality standards such as 1 part per million defect. And the equipment that is used to provide off-board programming has evolved significantly as well. Now, within EPS, we have been providing off-board services for the last 23 years. And I personally have been involved in the off-board programming business for the last 35 years. So I've seen a huge evolution in the quality standards available in how you handle programmable components, both microcontrollers and memory and logic devices. So we ourselves have developed our own capability within EPS Global, where we have a significant research and development facility in Brno city in the Czech Republic. And we have evolved our own component handlers over the years, I guess it's on the go for the last 15 years, into a situation where we not only provide off-board programming services, but we enable 3D coplanarity testing, we enable AOL testing after the devices have gone back into tape, and various other functions within the programming cycle, including securing the microcontroller with various new security partners that we have developed over the years into a product that we can stand over and guarantee the necessary quality standards.
Okay, and I'm assuming the way you're talking about these handlers, they're automatic. I mean, I assume they're automatic and they don't need manual intervention other than setting up jobs. So these are machines that you guys have developed yourselves.
Yes, they're completely automatic.
Okay.
And basically, if we talk about the programming job, we have a routine within the programming job. When we get an order for a new job from our customers, remembering that our customers will tend to give us their blank devices. So with blank devices, you could have, say, 10 different blank devices, but there's a one-to-many relationship between the blank device and the program device. So the customer may have 20 different programs that they want run in to the same blank device. And then on top of that, they will have cycles of up revs or engineering change orders as the firmware gets up revved for various things throughout the life cycle of the product, where all of those up revs in firmware need to be managed throughout the programming cycle. Okay. So what we tend to do is we have a first article master process, and the first article master process is done when we program the very first device of a new rev of firmware. And those a few sample parts are programmed and sent to the client with complex documentation that enables them to test the veracity of those parts, that they have been programmed correctly, that they have been handled correctly, et cetera, test them in their lines, and then certify that back to us that they approve that this program this part has been programmed correctly, and that enables us to put that rev of that part into production.
Okay, perfect. You mentioned two terms there that I think I'm going to have to ask you to explain, if you don't mind. You mentioned coplanarity, and then you mentioned checking. I think you said AOL once they're put back in the tape. Can you explain those terms for me quickly, if you don't mind?
Yeah, sure. 3D coplanarity testing is basically a process by which the device is subject to a test using complex cameras that will test the leads on the device in three different planes, the X, Y, and Z plane.
Okay.
And what we basically are trying to do is we're trying to prove to our client that we have not degraded the part in any way, shape, or form by carrying out the programming process. Okay. So this 3D coplanarity check is a check that's, we build in these coplanarity checkers into every machine that we make. And particularly in the automotive business, it's an absolute requirement that you have to 3D check the device after it has been programmed. So the device is usually presented either in tray or in tape. We automatically pick the device out, we program it, and we bring it back, and on the way back, it basically gets checked in all of the three planes.
Okay.
The AO, I call it an AOL process. It's an AOI process. It's AOI. It basically means automatic optical inspection. And
okay.
That is a process that's carried out after the devices have been placed back in tape. Okay. After the cover tape has been sealed on the top, the AOI camera then looks at the orientation of the device to make sure that they're all placed back in the correct orientation. So
okay, ready, I assume, for the SMT line so they can be picked and placed onto the board.
Yeah, so that we can guarantee, for instance, that there's not one or two devices that are placed back incorrectly, because if they go onto the board in the wrong
upside down,
it's basically going to be a big stink. Yeah.
Okay, fair enough. So let's say I'm going to put myself in the shoes of an OEM or a contract manufacturer and just throw some problems at you and see how you handle them. So, they say if a job's important, do it yourself. So in that vein, instead of outsourcing my programming to you at EPS or so that it can be programmed off board, why would I not just buy my own machine and get my own team to do it in-house?
Yeah, very good question. And the answer is, in a lot of cases, you would.
Okay.
But automatic programming equipment is very expensive, and it's akin to buying SMT machines. So it's got a very heavy capital overhead associated with it.
Like what are we talking?
Well, it probably starts at $500,000.
Oh, right. Okay.
So, and every programmable device, every different programmable device tends to have a different package associated with it. Programmable devices can come in many different packages, but two of the very popular packages are BGA, meaning ball grid array, and QFP, meaning quad flat pack. Now, a ball grid array is what it sounds like. It is a device that has all the contacts underneath in tiny little solder balls, and that can range anywhere from 64 up to, we've seen 400 different contacts underneath the programmable device, very complex devices. And then the QFP devices are devices that have pins, very delicate pins on all four sides. And again, the QFP devices can run anywhere from 24 pins up to multiples of 4, right up to 300 odd pins. So very delicate devices that require really delicate, precise automatic handling.
Okay.
And they're principally the devices that need to be checked at your 3D inspection.
Okay. And those machines then, you know, I'm the OEM and I've bought one of these machines for $500,000. Do I need different sockets to put in to handle these different types of devices? And I assume I need probably qualified people to maintain those machines. I'm just imagining these overheads.
Yeah, all the time. And the, you know, I think the SMT function is really a matter of trying to bring it down to the least number of risks that are associated with it. So, you know, you've got placement risks, you've got firmware revision risks, you've got, you know, if you're doing off-board programming, you've got lead times associated with getting new sockets in. Sockets are expensive. Sockets can cost $1,500 each. So all the time there's this constant overhead running through the management of an off-board programming site within a manufacturer's premises. What we tend to do is we have our programming centers, and we've got 23 programming centers around the world, and they're located in 14 different countries, mostly independently run EPS programming centers. And in some cases where we have relationships with very large clients, we will tend to build a programming center in their premises. So we take some of the very large tier one automotive manufacturers, we have implant programming centers in some of those locations. Now, because we're being asked to program all sorts of programmable devices, we build up a battery of programming adapters, which are common to a number of different customers. So in that situation, whereas our investment in adapters is very high in every location, there tends to be a large commonality between programmable devices. So you'll have, in memory, you'll have, you know, very common type packages, and micros are the same. So I suppose the economies of scale apply in that situation. Whereas if you have a manufacturer in a specific location that needs to buy a set of adapters, because usually you've got multiples of 4 again, 4, 8, 12 adapters associated with these automatic handlers, and he has to pay a couple of grand each for these things, it starts to get very expensive. And even the management of the hardware adapter itself becomes a very difficult job. Whereas we have routines, standardized routines around the world to manage all that process.
Okay, so you're making a strong case here. You mentioned firmware changes, and I guess that's something that OEMs or CMs encounter quite a lot. So, you know, they would often have the firmware changes, and at times have ended up placing components who have the wrong rev on a board, and they've had to scrap or rework them, which at the end of the day loses them money as a result. So, you know, if I came to you, what would you do to help there as regards the firmware changes?
Well, again, our entire process is built around the program part number. So, and in old database speak, the program part number is our keyed field. So if a manufacturer comes to us and with an engineering change order and said, look, we've had a change of firmware, we need you now to use this version. We'll say, okay, so what's the new part number for that? I mean, it's a very simple process from our point of view. No manufacturer that I know of in the world would have the same programmed part number for an up-revved firmware as the previous rev of software. So the program part number is our Bible, if you like. That's the one that we're driven by, and we have a whole hierarchy built up around that. So in our situation, when we receive instructions from our clients to program some parts, it's based around the program part number. The first time we do this, and it's part of the first article master process that I mentioned before, we build a bill of materials. And the bill of materials includes all of the instructions that are required, all of the special requirements. I think we've got something like 120 fields in our bill of materials on our system. And all of those need to be filled in. And the first article master process is driven by that bill of materials. So what our system does is it takes the specified blank device, it applies the detail on the bill of materials to that device. It automatically creates a works order with instructions. We program to that works order and we get the expected result out the back. Now, there's all sorts of checks and balances in there, but there basically is a new bill of materials for every uprev in firmware that we get.
So everything is clearly tracked and clearly managed throughout the process once it arrives at EPS.
Yes, that's right.
Okay, perfect. And, speaking of that, I've seen in our literature, that we can guarantee that, our failure rate is 1 part per million. How can we purport to say that?
Well, we're kind of judged on our record in relation to that. We have so many checks and balances built into our handling of these devices that any problems that arise are spotted within the process. And even if something happens that causes a retrospective investigation, we have log files that are maintained. The standard is 15 years, and so we can trace a lot code back for 15 years. In fact, we can trace it back longer, but the rules state that we need to trace it for 15 years. And that includes, right down to operator level, who actually initiated the programming run, at what time it was done at, how long the device was out of the dry bag, etc., etc. And all the details are recorded automatically within our system. So, and we have had situations where some of our customers have asked us to track back where there are perceived problems, and we have been able to give them all the details they need. In that regard, if you could imagine in an automotive control system, there are black boxes that basically are the ECUs that are used in the automotive industry. So when they open it, say they have a problem with a car and they isolate it to one specific ECU, they have to be able to open that ECU, have a look at the device, and come back and trace all of those details. So it's an extremely complex system that has been built up over many years of tracing and tracking.
And we're regularly audited by our automotive customers to maintain those standards and to pass those checks.
Yeah, several times a year by all customers.
Okay. So I guess we're coming to the end of our chat, and I'd like to get down to brass tacks. So what are the key financial and production efficiency advantages then of outsourcing my programming to EPS Global rather than doing it in-house?
Okay. So we negotiate a price per device, a programming price per device with our customers, and that's a measurable price. It doesn't move, and it doesn't move often enough for my liking, but it almost never gets more expensive. In these days of volume programming, it tends to become commoditized, so it's outsourced to us, and people then just forget about it, and then they look at the annual volumes of business and they negotiate with us based on those annual volumes. So, once you outsource it and the process is set up, either to there's many supply models. One is you can free issue those parts out to us and we'll program them and send them back to you. The other is you can consign those parts from your supplier to us. We will manage the use of those parts from our inventory on a consigned basis. We can give you full visibility of your inventory at that situation, or else we can buy the parts under your conditions from your supplier. We manage the transaction. We charge a finance charge and we charge a programming charge. And all of those models work very smoothly from our point of view. And in general, the rules around those things haven't changed in a long time.
So I outsource it to you under whichever business model works for me. And I kind of forget about it because I'm working with somebody I've audited and I trust, and the parts are just coming back to me ready to be placed on the board, pre-programmed on the assembly line. My line doesn't have to slow down at ICT because the parts don't need to get taken off and placed on the bed of nails to get tested and programmed at that point. So I guess I'm looking at a freer flowing line, which is going to save me a bit of money and also be more efficient to get more products out the other end. So I think you've convinced me on that point. So you mentioned, Mick, that you've got 23 programming centres around the world. So, if we're to take kind of a high level view look into the future, where do you see the industry going, or EPS going, in the next 1 to 10 years vista?
Yeah, so our long-term strategy is to continue our geographic expansion and also to continue our activity diversification within our existing engagements. So in a lot of situations, we have very good relationships with, the top 20 or 30 OEMs, contract manufacturers, tier one automotive suppliers, and they have many, many locations throughout the world. And what we tend to do is we tend to develop our relationship with those customers based on single or dual or multiple relationships, and try to expand those into further geographical areas. That's been a very, very successful strategy for us, and we would see ourselves continuing that. We have the equipment side of it nailed down in that we've developed handlers and they get more efficient every day. We have the new thing for us is secure programming. We have developed relationships with a number of specialists in this area where we have built their hardware into our hardware, and we can now provide very sophisticated levels of securing microcontrollers in all of our locations. And I guess the horrors associated with unsecure wireless devices can be dealt with in a separate podcast. But
yeah, and we've done that actually. We had a 2-part series, so we've talked about the risks and then the actual value to the manufacturer to actually secure their device and protect their brand and IP and their brand reputation and their users in the field. So I can see how that would be a future direction, or actually something we're undertaking currently.
Yeah, that's stuff we're doing today. We see that as a big growth area from our point of view.
Absolutely.
We also see our other activities. For instance, we're very busy now in providing custom carrier tape to our customers. Again, that's an opportunity to diversify in each one of our locations. We don't have carrier tape manufacturing in every location, but we have already invested heavily in carrier tape capability, with an emphasis on our client base, where, for instance, they may have components that normally would be hand inserted after the SMT process. And we work with them because we're a manufacturer services company. We work with them to try and get them into the SMT process, thereby saving them more money, making them more efficient. So in some cases, we've put very large connectors on carrier tape so that they can be automatically picked and placed on the board during the process. That's a developing and very interesting area from our point of view.
Okay, so service diversification, I guess, diversification or growth into the secure IoT space, and geographic expansion. It sounds like the future is bright. So I guess we'll leave it on that high note and say thanks a million to you for joining us today.
Thanks a lot, guys.